So today's topic is the continuation of differentiation. So problem number 8. Differentiate with respect to x fx equals to cos x cube into sin x to the power 5. So given fx equals to cos x cube into sin x to the power 5. Now differentiating with respect to x we get. So derivative of fx is f dash x. Now look at that uv formula uv. So this is constant, derivative of that one, plus this is constant, derivative of that one, Sure. So now, cos x cube. Now derivative of this one, derivative of sin is what? Cos. So cos x to the power 5. Now according to the chain rule, derivative of cos x to the power 5, So plus sin x to the power 5, sin x to the power 5. Now derivative of cos x cube. So derivative of cos is how much? Minus sin x cube. And again by the chain rule, derivative of x cube. This is x cube, so derivative of x cube. So now derivative of x to the power 5 is what? 5x to the power 4 into cos x cube into cos x to the power 5. So now look at that, this is plus minus. So derivative of x cube is what? 3x square. So 3x square into sin x to the power 5 into sin x cube. Got it? It is your answer. So now problem number 9. Differentiate with respect to x 2 tan x by tan x plus cos x whole square. So let us consider y equal to 2 tan x by tan x plus cos x whole square. Now differentiating with respect to x we get. So look at that. If you consider this total one like x, so x square. Derivative of x square is what? 2x. So 2 into x. Got it? That means 2 into 2 tan x by tan x plus cos x. Now derivative of this one according to the chain rule. So derivative of this one means u by v. Got it? So it is your u, it is your v. So now what is the derivative? U by v formula v square. So v square means tan x plus cos x whole square into this one constant. So tan x plus cos x constant into derivative of 2 tan x. How much? That is 2 sec square x minus 2 tan x is constant, derivative of this total one, tan x plus cos x. So derivative of tan x is what? Sec square x, and plus cos x is derivative of cos x is minus sin x. So sec square x minus sin x. Got it? So now look at that. There is a 2, there is a 2. So this 2 common, this 2 and this 2. So there are 3 2. So this means 8. So 8 tan x into, look at that, tan x into sec square x, plus cos x into sec square x means 1 by cos square x. So cos x by cos square x, how much? 1 by cos x. Got it? Minus tan x into sec square x, minus plus tan x into sin x, Sure. So tan x into sec square x, cancel out. So 1 by cos x means what? So now look at that. There is the tan x plus cos x whole square, and there is tan x plus cos x. So tan x plus cos x whole cube. And look at that. 1 by cos x means sec x, and this is tan x sin x. Got it? It is your answer. So now problem number 10. Find the derivative of sin x square at the point root under pi by 2. How much? Let fx equal to sin x square. With differentiating with respect to x, we get f dash x equal to how much it is? Derivative of sin. What? Cos sin x square. Got it? So now again derivative of sin x square, that is cos x square. Again by chain rule, derivative of x square is what? 2x. Got it? So now instead of x put pi root under pi by 2. So f dash of root under pi by 2 means cos sin pi by 2 root under pi by 2 whole square means only pi by 2, and cos root under pi by 2 whole square means only pi by 2, and that should be 2 into root under pi by 2. So look at that, cos pi by 2 means 0, so the answer is 0. Sure. So now problem number 11. If y equal to cos x plus sin x by cos x minus sin x, prove that dy dx equal to sec square pi by 4 plus x. How much it is? How to solve it? Wow, given y equal to cos x plus sin x by cos x minus sin x, and that should be, so dividing both side by, both numerator and denominator by cos x. So cos x by cos x 1, sin x by cos x tan x. So cos x by cos x 1, sin x by cos x tan x. So 1 plus tan x by 1 minus tan x. Instead of 1, write tan pi by 4 plus tan x by 1 minus in 1 into tan x. That means tan pi by 4 into tan x. Sure. So this means tan pi by 4 plus x. Sure. So now differentiating with respect to x we get. So derivative of tan is what? Sec square pi by 4 plus x. And now according to the chain rule, derivative of this one, that means derivative of pi by 4 plus x, and that should be derivative of pi by 2 0 and derivative of x is 1. So 0 plus 1 means 1. So dy dx equal to sec square pi by 4 plus x. So now problem number 12, differentiating with respect to x, root under sec x plus 1 by sec x minus 1. So sec x means 1 by cos x plus 1, 1 by cos x minus 1. So after simplification, we got root under 1 plus cos x by 1 minus cos x. And according to the submultiple angle, 1 plus cos x means 2 cos square x by 2. And 1 minus cos x means 2 sin square x by 2. So 2 cancel out. So root under cot square x by 2, that means cot x by 2. Now differentiating with respect to x, we get dy dx equal to derivative of cot x means minus cos square x by 2 into derivative of x by 2 means what? Half. So answer is minus half into cos square x by 2. So now problem number 13, differentiated with respect to x, root under 1 minus tan x by 1 plus tan x. How much it is? So tan pi by 4 means 1 minus tan x, and this should be 1 plus tan pi by 4 into tan x, and that should be the formula root under tan pi by 4 minus x. Now differentiating with respect to x, consider this total one like x. So root under x derivative is half of tan pi by 4 minus x minus half minus 1 means minus half. And now again derivative of tan pi by 4 minus x according to the chain rule. So this should be 1 by 2 into root under tan pi by 4 minus x into root under, look at that, derivative of tan is what? Sec square pi by 4 minus x into, according to the chain rule again, derivative of pi by 4 minus x, and that should be minus 1. So the answer is minus sec square pi by 4 minus x by 2 into root under tan pi by 4 minus x. So now problem number 13, differentiate with respect to x, root under x square plus 1 minus x by root under x square plus 1 plus x. So now multiplying both sides, both numerator by root under x square plus 1 minus x by root under x square plus 1 minus x. So this should be root under x square plus 1 minus x whole square, and that should be a plus b, a minus b, formula a square minus b square. That means root under x square plus 1 whole square minus x square. So that should, after simplification, we got x square plus 1 minus 2 into x square plus 1 into x plus x square by x square plus 1 minus 1. So x square cancel out. So this should be 2x square plus 1 minus 2 into x into root under x square plus 1. So now differentiating with respect to x, we get this should be 4x, and now UV formula 2 is common. So x into root derivative of this one, that means half of x square plus 1 minus half into x, derivative of x square plus 1 is 2x. So x into 2x means 2x square. And look at that, plus this one is constant and derivative of x is 1. So x square plus 1. So 4x minus 2 into x square by root under x square plus 1 plus root under x square plus 1. After simplification, we got so x minus 4x minus 2 into x square plus 1 by x square root under x square plus 1. So this should be 2x square plus 1. So it is your answer. So now problem number 15. If y equal to x plus root under x square minus 1 whole to the power m, prove that x square minus 1 into dy dx whole square, that is equal to m square y square. How to solve it? Given y equal to x plus root under x square minus 1 whole to the power m, differentiating with respect to x, we get dy dx equal to, formula is, if we consider this total one like x, so x to the power m, formula is m into x to the power m minus 1. So this is your x, put it. And now derivative of this one, according to the chain rule. So derivative of x is 1 and derivative of this one is half into x square minus 1 whole to the power minus half into derivative of this one, this under root of x square minus 1 is what? 2x. So 2x. 2 cancel out and this should be 1 plus x by root under x square plus 1. Cross multiply, we get x root under x square minus 1 plus 1 by x square root under x square minus 1. So look at that, this one is x to the power this one to the power m minus 1 and this one to the power whole to the power 1. So this should be added. So what happened? M into x plus root under x square minus 1 whole to the power m by root under x square minus 1, and that should be your y. So put it y. So y into m by root under x square minus 1. So now dy dx equal to ym by root under x square minus 1. Now squaring both sides we get dy dx whole square equal to m square y square into x square minus 1. Got it? Now cross multiply x square minus 1 into dy dx whole square, that should be m square y square. Okay, thank you so much.